two balls P and Q are projected from the edge of a cliff. P is projected horizontally at speed v and Q is projected vertically upwards at the same speed. The time taken for P to reach the ground is Tp and the speed at impact with the ground is Vp. Air resistance is negligible. What is the time taken to reach the ground and the speed at impact with the ground for Q? So the initial velocity vector for P is horizontal vector of magnitude v, and it travels to the ground, and the initial velocity vector for Q is vertical vector, and it also travels to the ground, and there is the same change in height, and let it be h. It's useful to consider law conservation of energy. Total energy before is equal to total energy after, and we consider this point to be before, this to be after, and for Q this to be before, this to be after, and let this level, this ground level, be as y is 0, so that total energy before it's kinetic m v squared over 2. Notice that v is the magnitude of the velocity vector or speed. It doesn't matter that it's horizontal or vertical or at some angle. So it's the magnitude of the velocity vector, not a component, plus gravitational potential mgh is equal to gravitational potential after is 0, because we chose this to be y to be 0, and is equal to m, and let the magnitude of the velocity vector or speed at the ground be v prime, so m v prime squared over 2, and this velocity vector is tangent to the curve, so it looks like this, and its magnitude is v prime. It's not necessary here, but it has two components since acceleration is g and it's vertical. This horizontal component of the velocity remains the same, and it also has a vertical component according to v is u. It's another v, it's just a formula from a data booklet. It's a vector equation, and in projection onto y-axis, u is its component is 0. Why? Because the initial velocity vector is horizontal and its component onto a vertical axis is 0. A is in opposite end of magnitude g, so g, so minus gt, and it is equal to the final velocity vertical, and minus, it means in opposite direction, so downwards, and of magnitude gt, so its magnitude is gt and in this direction, and the sum of these two vectors is the velocity vector, and its magnitude is v prime. For Q, law of conservation of energy becomes also mv squared over 2 plus mgh is mv prime squared over 2. But for Q, v prime, it's vertical vector downwards, v prime. So we can conclude that at the surface of the ground, they have the same speeds, the same magnitudes of velocities. Speed at impact is the same. And now let's consider time. So let's consider this formula as is ut plus at squared over 2 time to be involved, and it's also a vector equation. And And for P, it becomes its displacement, and the displacement for P, it's negative h, is, and we consider in projection or in components on the vertical axis, let it be y-axis, which is vertically upwards. So displacement is negative h, because it moves downwards. U vector, its component is 0. Why? Because it's a horizontal vector and its component on the vertical axis is 0. And acceleration is g, it's downward, so its component is minus g, and it is squared over 2. Hence Tp is square root of 2h over g. And now let's consider Q. This same equation. Displacement is also negative h, is u, it's the initial velocity vector, and its component or projection on the y-axis, it's parallel in the same direction, so it's plus v, so vt, and minus gt squared over 2. It's t p, it's t q. And we can see that quadratic equation arises, and let's use discriminant, and let's rearrange. So gtq squared over 2 minus vtq minus h is equal to 0. And discriminant is b squared minus 4ac, so v squared minus 4 ray c, so plus 2gh. And roots are minus b plus minus root of d, and divided by 2a, so over g. And notice that, for example, when v is 10, it becomes 100 plus something, so square root is greater than 10, so it cannot be minus, because t becomes negative, and it's impossible, so it's plus. And it's clear that when v is 0, we get this, but when v is not 0, it becomes larger, so some value plus some value which is larger than root of 2g, so definitely it's greater than Tp. So it's greater than just square root of 2h over g. So time is greater, so it's C. And that's all for this question.